Ever wondered what makes a self-driving car safe, even when every single part of it is working perfectly? Well, today we're going to peel back the curtain on a hidden but absolutely crucial safety standard that stops even the most advanced cars from becoming, well, perfectly unsafe.
I want you to picture this. You're cruising down the road in your self-driving car, totally relaxed. All systems are online, every sensor is working flawlessly, and then, bam! The car slams on the brakes for a shadow. The thing is, the car didn't break. It wasn't a failure. It just got confused. And that's where our story really begins.
And that right there is exactly what this crucial safety standard called SOTIF is for. You can think of it as a rulebook for when things go wrong, even when nothing is actually broken. It's all about making sure a car's brain can handle the messy, unpredictable real world, not just some perfect computer simulation.
This slide really gets to the heart of it. See, traditional car safety, that's all about stopping things from breaking. A faulty sensor, a software bug, that kind of thing. But SOTIF, it's a completely different ballgame. It asks, what happens when everything is working perfectly, but the car still gets it wrong because of something like heavy rain or a confusing reflection on the road? All right, so how do engineers actually do this? How do you build a car that's not just smart, but wise? Let's break it down. We're going to look at how the car sees, then how it thinks, how it all comes together in the real world, and finally, how we can ever learn to actually trust it.
First up, what's the big idea behind all this SOTF stuff? It's not just about ticking boxes on some safety checklist. No, it's about building a car that's safe in the real world with all its chaos and unpredictability.
Think of it like this. Engineers are basically explorers, trying to map out every single dangerous what-if a car could possibly face. SOTIF is their compass. It guides them to test every single one of those scenarios until they're positive the car can handle it. The whole point is to turn those scary unknowns into knowns that we've already solved. Okay, so where do you even begin? Well, you start with the car's senses. Let's take a look at how engineers make sure the car's eyes, its whole network of cameras, radar, and LiDAR, are actually sharp enough for the job.
I mean, it's not enough for the car's eyes to just be open, right? They have to be sharp. So engineers put these sensors through a total gauntlet of tests. They'll ask stuff like, can this camera spot a person from a football field away? Or is the signal strong enough to cut through the noise of a rainy day? They'll even create virtual fog and blinding sunlight in simulations just to see how the sensors hold up. And they even check how things degrade over time, just like our own eyes.
We've all been there, right? I mean, who hasn't been blinded by sun glare or seen a weird reflection that makes you jump? Well, cars deal with the exact same stuff. A camera can get totally washed out by glare, radar can see ghosts that aren't really there, and get this, a camera can even mistake old skid marks on the road for lane lines. These aren't software bugs, they're just the fundamental limits of the technology. All right, so the car can see, that's step one. But can it think? Now we're getting to the brain of the whole operation, the part that has to take all that sensor data and actually decide what to do. This is where seeing becomes doing. It's kind of like teaching a teenager to drive. Yeah, you teach them the rules of the road, but what's really important is teaching them what to do when things get hairy. That safe fallback is the car's version of a pull over and call for help plan. It might just be the most important lesson of all.
And this is what engineers call the minimum risk condition. It's basically the car's emergency escape plan. So let's say a sudden snowstorm hits and the lane markings just vanish. The car has to be smart enough to know it's in over its head. That's when it kicks in this pre-programmed move to get itself to safety, like safely pulling over to the side of the road and stopping.
Okay, we've got the eyes, we've got the brain. Now, let's put it all together and see what happens when the rubber literally meets the road.
And this is where things get really, really tricky. It's like a band where every musician is an absolute genius, a virtuoso, but when they all play together, it's just a total mess. A camera can be perfect, the software can be flawless, but when you put them together in a moving car, things can get weird.
And this brings up a question you've probably never even thought to ask. What in the world does your car's bumper paint have to do with its safety? The answer might actually surprise you.
Yeah, it turns out a lot. See, some cars have radar sensors hidden behind the bumper, but certain kinds of metallic paint can basically act like a blindfold for that radar. We're talking about just a tiny bit of signal loss, 1.25 decibels. Doesn't sound like much, does it? But that can be the difference between the car seeing a cyclist and not.
And this is why SOTIF forces engineers to really sweat the small stuff, like how does a curved windshield distort what the camera sees?
Or what happens if a sensor is mounted just a fraction of an inch off-center? You'd be amazed how these tiny little details can have huge consequences when you're hurtling down the highway.
And now, we face the final boss, the AI itself. How do you actually trust a brain that, let's be honest, you can't fully understand?
It's kind of like the difference between a cookbook and a master chef, right? A cookbook has a specific recipe for every single dish. But a master chef? They just know. They improvise, they create, they feel it out. Self-driving AIs are a lot more like the chef, which means you literally can't test every single recipe it might cook up.
So what do? Well, if you can't test everything, you test the hardest stuff. It's like a boxer training for a championship fight. They don't just spar with anybody, they spar with the toughest opponents they can find, over and over and over again. That's what this accelerated testing is all about.
Look, we have to be realistic here. We can't build a car that will never, ever make a mistake. That's just not possible. But what we can do is build a car that is provably safer than a human driver. The goal is to get that residual risk, the tiny chance of something still going wrong, so incredibly low that we're all comfortable with it.
And that really is what SOTIF is all about. It's the roadmap. It's how we systematically turn those what-ifs and our fears about self-driving cars into a solid foundation of trust. It's how we build a future where we can all feel safe on the road, no matter who or what is behind the wheel.
So we're getting really good at preparing for the dangers we know are out there. But what about the ones we don't even know exist yet? The true unknown unknowns. How do you build a car that can handle a surprise that no engineer could have ever predicted? Now that is the billion-dollar question. And the answer is going to define the future of how we all get around.